In this video, we are going to see the topic under the model 5. It is a chi-square distributions. Okay. So, chi-square distributions, it is denoted it's like this. It's a chi-square distributions. So, it is a distributions provides a measures of a correspondency between the theoretical frequency and observed frequencies. So, the formula for the chi-square distribution is chi-squared equal to summation of OI minus EI the whole square by EI. Degrees of freedom is n minus 1. Okay. So, it is a chi-squared formula which can be expressed. What is that? The finding the provide the measure of correspondency between of what is that? OI is nothing but is observed frequency. EI is nothing but expected frequencies or theoretical frequencies. Okay. So, the formula for chi-square is what is that? Summation of OI minus EI the whole square by EI, where the degrees of freedom is n minus 1. So, this is a table which you can use for the chi-square distributions value based on your degrees of freedoms. Okay. So, we'll go for the first question. A dice is thrown 264 times and the number appearing on the face X follows the following frequency distributions. So, the number appearing has been given on the face of X, that means on the face of 1, 2, 3, 4, 5, 6. Okay. So, what is a frequency is nothing but it is a 40, 32, 28, 58, 54 and 60. And calculate the value of your chi-square. So, the question has been given, the dice is thrown 264 times. So, the n is given 264 number of times. Okay. And has been given the x value and the frequency value. So, what is that? The question is directly given the to calculate your chi-square. As per the formula, what is your chi-square? It is observed frequency minus expected frequencies, right? So, which we are going to find your observed frequency from the frequency data, and also we are going to calculate your expected frequencies. So, we can go for your solutions. Okay, once you have found these two frequencies, you can able to directly go with your chi-square formula. So, the solution is the frequency is the given data the observed frequency. So, what has given? That is 40, 32, 28, 52, 58, 54, 60 is called as an observed frequency which is given in the data. Assume that the dice is unbiased. The expected number of frequencies for the numbers. What is that? The numbers of the face which is given. It is 1, 2, 3, 4, 5 and 6 to appear on the faces is. What is that? It is a total number of times. It will appear in the number of times is 264 by what is that? We have 6 faces, right? By 6. Which is equal to 44 in each, isn't it? So, in the average, the expected frequency is a 44 for the each dice. Okay. So, now the data it will go, the number of dice in the phase 1, 2, 3, 4, 5, 6. The observed frequencies is OI, isn't it? So, it is 40, 32, 28, 58, 54, 60. Now, expected frequencies is nothing but it is an which you have already calculated on each. It will be having 44 for your expected frequency. So, that's why it's written all will be a 44. Now, calculate your chi-square, right? Chi-square is equal to summation of OI minus EI the whole square by EI. Substitute, you will get a chi-squared value is 22. Clear? So, that is what the question is asked to calculate. Now, the second question. 5 dice were thrown 96 times and the number 1, 2 or 3 appearing on the face, the dice follows the frequency distribution as follows. So, what is that? The 5 dice were thrown 96 times. The total number of thrown is 96 times, and when the out of 96 times the number 1, 2 or 3 appearing on the face has been given in terms of frequencies. So, number of dice is showing 1, 2 or 3. It's 5, 4, 3, 2, 1. 0 is nothing but there is no there is not showing the dice. Okay. Now, the frequency is 7, 19, 35, 24, 8 and 3. Okay, for the frequencies. Now, the question is asked to test the hypothesis that the data follows a binomial distributions. So the question is directly given, you should use the binomial distributions, and chi-squared value of 0.5 is 11.07 for 5 degrees of freedom. Now go with the solution. What is that? The data given the observed frequencies, and we need to calculate expected frequencies in it. So what has given as an observed frequency? So it is observed that it is the frequency has been what is that? And showing the dice of 1, 2, 3 as a phase, right? So now we need to calculate expected frequency. The theoretical frequency of getting 5, 4, 3, 2, 1, 0 success with 5 dice are respectively the successive terms of the binomial expansions. Okay. Now, what is a binomial expansion? So, first you can binomial expansions, you know what is that? You have a p of x, right? So, p of x is equal to ncx into p power x into q power of n minus, what is that? N minus x. So, in that n minus x, so you should find n. So, n as in 5 times, you get number of experiment. And then, what is that? Because I have the terms of 5, so we have taken success with the 5 dice. And you have to find your probability of success and the failures also we should find out. Okay. So now you can go with your p value. What is that? The probability of success is nothing but is an 1 by 2 here. And then failure also 1 minus 1 by 2 will get 1 by 2. So now on substituting that, I can get my binomial expansion of p of x. Okay. But it is experiment has been done for, what is that? The question has been given. The dice was throwing 96 times. Okay. So what is that? 96 into, you have to find it your p of x. Okay. So the after calculating, I can get 96 into 1 by 25 and 96 into 5c, and right, 5c 1 into 1 by 25 and up to etc. 96 into 1 by 25, I can get the expansions. Okay. That is, you can calculate, you will get your, what is that? Expected frequency is 3, 15, 30, 15, 3. Thus, OI and EI I will get, that is observed frequency and expected frequencies. So, you can write it here all the frequencies, then you can calculate your difference easily to calculate your chi-square. What is it? Chi-square is equal to summation of OI minus EI the whole square by EI. So, substitute that value, you can get the answer is 11.7. So, chi-squared value, the question is asked to test the significance, right? So, what is that? At the level of 5%, and the values already is given under the degrees of freedom of your values, right? So, use that value 11.7, which is greater than of your chi-squared value. So, what is that? The chi-squared value which is mentioned, it is for 11.07. So, which we got it actually, it is 11.7, which is greater than value. So, the hypothesis that the data follows the binomial distribution as rejected. Okay. So, we'll go with one more example. Fit a Poisson distributions for the following data and test the goodness of it. Given that chi-squared of 0.05 is 7.815 for 3 degrees of freedom. Okay. So, what is that? X value is given 0, 1, 2, 3, 4 and the frequency is given 122, 60, 15 to 1. Now, what is that? The question is clearly given as a Poisson distributions, and we know the Poisson distribution which is related with in terms of your mean. So, first find your mean. For that, sum of the frequency by number of your sum of the values by number of a data, you can make it. Here it is related with your, what is that? It is with x and f, which is nothing but your discrete series, right? So, you have to multiple x into f and you can summation. It is summation of x into f for the numerator, and denominator is nothing but sum of the frequency, right? So, you can multiple 0 into 121 plus 1 into 60 plus 2 into 15. So, use that discrete series formula to find your mean. You can get as 0.5. So, mean is nothing but m for the Poisson distribution. So, substitute in p of x, m power x into e power minus m by x factorial is your Poisson distribution. When you incorporate that value, you can able to get it your p of x. But it is given up to, what is it? 200 is your summation value of f of x, frequency values. When you can find it your f of x, what is that? As per the formula, n into p of x. So n is nothing but sum of your frequency here. It is out of 200. So 200 into p of x. You can substitute it. And e power of minus 0.5 value, you can directly substitute to make it a calculation. Will be easy. So you will get 0.6065. So I'll get your f of x value, multiple with your 200 into e power minus 0.5 value, will get 121.3 into 0.5 the whole power x by x factorial. So now you are going to find it with a three theoretical frequencies are. What is that? Replace x values, each x value to this f of x. So what I can get? 121, 61, 15, 3 and 0 for your values of your theoretical frequencies for the corresponding x values. So now you can see that I'm going to find out here, I'm going to make it your observed frequency and your expected frequency. So observed frequency which is given in the question, right? So you can write it your observed frequencies, which is what is that? 121, 60, 15 and 2. But the last one I'm supposed to add with a plus 1 which is equal to 3 will give for your last values. Okay. So the expected frequencies which you have 121, 61, 15. 3 plus 0 I made it because you have the last one. We have 0 plus 0, 3 plus 0 which is equal to 3. So why it is added for the last value, which is you can see that the number of data has been given here in the question, which is for your number of samples is there 1, 2, 3, 4, 5, right? But the degrees of freedom has been given for your 3. So degrees of freedom will be calculated with n minus 1, right? So you are supposed to have a sample with 4. So 4 minus 1 we will get 3 exactly with the 3 degrees of freedom. And one more thing, when you have a frequency values is in 0, when you calculate with the chi-squared formula, the denominator will not be a 0 because it will go expected frequency is 0. It will get as an infinity. To avoid the chi-squared value of your infinity solution, we are going to add it your last values. Okay. Since the last of your expected frequency is 0, we shall club it with the previous one. So when you club it with the expected frequency and similar, you can club it with your observed frequency also. So this is a major reason when you club it. Okay. And you can compare with the degrees of freedoms is given with the 3 and that also will be used it here. So using that concept you can compare it. We are supposed to club it with the observed frequencies and the expected frequency of last values to be added. Okay. So now what is your chi-square? It is a summation of OI minus EI the whole squared by EI. So I can get it the value is 0.025. So chi-squared is 0.025 which is a less than of your table value. The table value is 7.815 which is already given in the question. So therefore the fitness is considered good because we got it less than. The hypothesis that the fitness is good can be accepted. Okay. Thank you.